The End of the Universe, Part 1. Everything must end at some point, but does the cosmos itself fall under this category? In that case, how? Also, when? Even though it may be difficult to envision a disaster that would have enough impact to alter all of existence, physicists believe that the end of the world is inevitable and may occur sooner than we think. We'll take a look at some popular theories on how and when the universe could end. Physicists examine the origin of the universe to determine how it may come to an end. The Big Bang, an event that caused space and time to emerge from an immensely dense singularity, occurred around 13.8 billion years ago. From that moment on, the cosmos quickly expanded as matter cooled, condensed, and formed galaxies, with all the stars and planets they contained. But despite this, the universe is still expanding, and it is doing so faster than ever before, owing to a mysterious element known as dark energy. As the name of the force implies, we have very little understanding of how it operates or why it pushes things apart from one another. But it has some fairly significant consequences for the eventual destiny of the universe. The results depend on how the values in the next two models are changed. The Big Freeze. The Big Freeze is the most plausible scenario based on our best predictions of the development of the cosmos. Calculations indicate that dark energy will continue to accelerate the universe's expansion indefinitely, and if it does, the cosmos will experience a protracted death that lasts for a googol years. That is, 1 followed by 100 zeros in that incomprehensible amount. The stars would begin to turn crimson and eventually disappear. If you could fast forward through billions of years and see a small area of the sky, this is due to the fact that as the universe expands, their light's wavelength would gradually shift towards the red end of the spectrum until it becomes utterly invisible to human sight. The distant stars and galaxies would still exist, at least for a few trillion years, even if you couldn't see them. However, over time, as the universe expands, less dust and gas is concentrated in any one area, making it impossible for new stars to form there. Stars gradually stop reproducing, becoming an endangered species that finally becomes extinct when the last of them dies out. So starts the degenerate era, which will last for around 100 trillion years. Only white dwarfs, neutron stars, and black holes are left at this time, but even these will eventually vanish. Certain white dwarfs and certain neutron stars will gradually cool into invisible, dormant black dwarfs, while other neutron stars will collapse into black holes. There will only be black holes remaining by the year 10 tredecillion, a 1 followed by 43 zeros. Even these aren't immortal since, as Stephen Hawking predicted, black holes gradually emit radiation before dissipating. The universe enters its ultimate era, the dark era, after about 1 googol years. After all, black holes have also vanished. Their surviving loose particles will have the most solitary life conceivable, seldom having the opportunity to go within a light year of one another, much alone communicate. Light and matter are distant memories, and for all of eternity, nothing else will ever occur. The Big Rip. A comparable event results in a considerably more spectacular death that occurs much sooner. According to this theory, dark energy accelerates the universe's expansion exponentially rather than steadily, ultimately rupturing reality itself in a final event known as the Big Rip. Even with the greatest powerful telescope, there is a physical limit to how far into space humans might ever view. The speed of light sets a limit at which objects are too far away from their light to have had sufficient time to reach Earth. The observable universe is the name given to this area. According to the Big Rip hypothesis, the observable universe is perpetually contracting as a result of the exponentially accelerating expansion, pushing more and more items over that limit. The basic forces, like gravity or electromagnetic, can no longer interact between any two things that are separated beyond this threshold. Large-scale structures of the universe will start to collapse as that distance decreases because gravity won't be able to keep galaxy clusters together when they start to dissolve. The galaxies themselves will eventually experience the same thing, sending stars out on their own course. Planets won't be constrained by their orbits around stars in the future because the cosmic event horizon will eventually contract to a size smaller than a single star system. That event horizon would eventually become smaller than the size of molecules in the closing moments of its life, upsetting the forces that hold everything together and destroying stars, planets, and everything on them. Finally, the free atoms would be broken up into their component parts. The structure of spacetime itself is the last casualty. If this scenario materializes, according to the researchers who developed the model, the cosmos would have around 22 billion years to live. Fortunately, some scientists think that this scenario includes unrealistic assumptions and is thus less likely to occur than some of the other theories. We'll talk about 3 distinct models in Part 2 of The End of the Universe, including the Big Crunch, the Big Bounce, and the Big Slurp.